Hi everyone. To start today's lesson, I thought I'd bring a little humor. So for my joke for you today, it is, what is the bird's favorite subject? Did you guess it yet? It's algebra. Get it? Okay, so today's lesson is about operations with complex numbers, and from the other video, you remember hopefully that I stands for an imaginary number, and then that is part of a complex number. So before we begin, let's write down our little way to remember powers of I. So I1, the middle two are negative. And we go remainder 1, remainder 2, remainder 3, and remainder 0. Or if you use your calculator, this is 0.25, 0.5, 0.75, and then no remainder, so 0.0. Okay? So if we take a look at the first example, remember how I said in the previous video that you cannot have I be bigger than a power of 1. So you see I to the third, which means we're not done. So look off to the side. I1, the middle two are negative, so this is a remainder of 3. So this equals negative I. So this is going to be 5 times negative I, so negative 5I. Okay, and it also might help for you guys to write this down to maybe, so I1, the middle two are negative. This is I to the first, I to the second, I to the third, and I to the fourth. So notice that that matches what the remainder is, but just another way to look at it. Okay, so let's take a look at the second example. So we do have work to do on this problem since there's I to the second. So I to the second equals negative 1. So this is negative 8 times negative 1, which equals 8. Okay, I to the second is going to be the biggest one for you guys to remember. I to the second equals negative 1. Okay, so since we are multiplying here, not adding or subtracting, we basically just treat it like terms. So if you had 7x times 8x, that would be 56x squared. So this is going to be negative 56I to the second. I can't leave my answer like that because I can't have power of I being bigger than 1. So I to the second is negative 1. Multiply those two together. Remember that this is multiplication between here. That's not subtraction. This is multiplication. And so that equals 56. Okay. All right, and then the next example. So once again, that's not addition or subtraction. It's all in parentheses. So we're going to multiply all the numbers together. And that's going to give me negative 48. And then multiply all the i's together, and that gives me I to the third. I to the third equals negative I. So this is negative, just kidding, this is 48I. Okay, so negative times a negative is a positive. We have I to the first, so we're good to go. Okay. All right, next example. You're going to treat this just like you normally would. You're going to go ahead and just distribute. Just because there's an I in it doesn't change the process on how you would go about this problem. So we're going to go ahead and distribute. So that's going to give me 18I plus 3I squared. You can't leave a power bigger than 1. So this is plus 3 times negative 1. So now we have 18I minus 3. So if this was on a quiz, you would get credit, but you wouldn't get full credit because it's not written in the correct complex form, which means the real part has to come first. So negative 3 plus 18I is my final answer. Okay. All right, let's do another example together, and then I'm going to have you guys try one on your own. So once again, just go ahead and distribute the I through. So this is 5I minus 6I squared. We need to take care of our powers of I, so this is minus 6 times negative 1. So we have 5I plus 6. Can't leave our answers like that though. Must write them in the correct form. So 6 plus 5i. Okay, go ahead and try the next example and hit pause and then check your answer when you're done. Okay, so you guys should have gotten negative 12 minus 18i. All right, so that was just distributing one number in front. Let's go ahead and FOIL these. So this is going to be 8. Then we have minus 16i plus 2i minus 4i squared. Okay, so I to the first is fine, but anything bigger than that we need to take care of. And like I said earlier, I to the second is going to be the biggest one that you're going to see the most. So this is negative 4 times negative 1. So this is plus 4. Then from here, we're going to practice just combining like terms. So you're going to combine the real parts together, and that gives me 12. And then you're going to combine the imaginary parts together, and that gives me minus 14i. And that's your answer. Okay? All right. Same thing. Let's try the next one on our own. So hit pause. Okay, you guys should have gotten 9 plus 5i. Okay. Okay, let's go ahead and do example 10 together. Remember, don't be that person that gets the sad face on your quiz or test. Remember that you have to expand this out. So this is 2 plus 2i times 2 plus 2i. So we're going to go ahead and distribute. So 4 plus 4i plus 4i plus 4i squared. Simplify powers of i, so this is plus 4 times negative 1, which is negative 4. And then combine the real parts together. So that's going to be 0, so that cancels each other out. And then combine the imaginary parts together, which is going to give me 8i. Okay. All right, now let's get combined kind of the first 2 days together. So remember to take care of I first. So you know how people always tell you to take care of you first? Well, now just say take care of I first. Okay, so I must take the i's out first. So this is negative 1 times root 5 times root negative 1 times root 25. Now technically you can skip this step and just go right to here. I'm just doing it to make sure you all see where the i's are coming from. And then simplify this. So this is I root 5 times 5i, because the square root of 25 is 5. And then multiply outsides together. So 5i squared root 5. Of course, this is not done yet because I must simplify powers of I. And remember that I squared is negative 1. And this is not multiplication, or excuse me, not subtraction. It is multiplication, so negative 5 root 5. Okay, so take care of I first. So let's take a look at number 12. So once again, take care of I first. So I root 7 times I root 3, and then multiply it. So I squared root 21. Now 21 does not break down. Well, it breaks down to 7/3, but doesn't make a perfect square. However, I squared needs to be simplified. That's going to be negative 1. So my final answer is negative root 21. Okay. All right. Let's go ahead and take a look at 13. And then we're going to skip 14. So once again, take care of I first. So 5i root 6 times root 12. Now you can multiply these together first, or you can simplify them. Let's just say you multiply them together, so that's going to be 72. Do a little side work. So I can take a 6 out, and I'm left with 2. So 5i times 6 root 2. So 30i root 2. All right, so let's skip 14 and let's go to 15. Okay, for 15, you cannot simplify those negatives and make it a positive. You must take care of I first before you can take care of anyone else. So this is going to be 6 plus 3i minus I root 25. Now go ahead and take a look at all of the things you need to simplify. So that's going to be minus 5, because the square root of 25 is 5. And then combine the imaginary parts together. So 6 minus 2i. All right, and then the last thing we need to talk about is on the next page, everybody's favorite, division. So just like radicals, we sadly cannot leave i's in the denominator. We have to rationalize those. So if you do not see addition or subtraction, you need to multiply by I if there's one in the denominator to get rid of it. So I do not see addition or subtraction in the denominator, so I'm going to go ahead and multiply top and bottom by I. So 4i over I to the second. Do not cancel those i's. If you do that, you just undid everything you just did. Okay? Instead, use our powers of I. So this is going to be negative 1. So we have 4i over negative 1, and we should not leave a negative in the denominator, so negative 4i. Okay? All right, let's take a look at number 2. Actually, you can notice in number 2, you can simplify this first. There's no addition or subtraction so in the denominator, so don't need to worry about anything with the heart. So 1 over 3i. We have an I in the denominator. We can't leave it there. Okay, and just because there's a 3 there, it doesn't matter. As long as it's not addition or subtraction, we just multiply by I, top and bottom. So I over 3i squared. Once again, do not cancel the i's. Use your powers of I. So we get negative I over 3, or you can write it as negative 1/3 I, which is probably how you'll see it more commonly used. Okay. All right, let's take a look at example 3 then. So it doesn't matter if there's addition or subtraction in the numerator. It only matters when it's in the denominator. If there's addition or subtraction when you're trying to rationalize. So once again, all we do is multiply by I. Please, 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 please. Do not cancel these i's. That is illegal because I was not completing the heart. And we need some love these days, so don't give me a half of a heart. All right, so we're going to distribute. So 11i plus 7i squared all over 4i squared. Once again, do not cancel the i's. Instead, use your powers of I. So this is 7 times negative 1, and this is 4 times negative 1. So now I have 11i minus 7 over negative 4. So if you're doing this on a quiz or test, you would get a lot of credit, but you wouldn't get full credit because you have not completely simplified the problem. 1, you shouldn't leave a negative in the denominator. And 2, remember that the I has to come second. So I know I just got done saying that I is first, but when you write it, I is second. So we have negative 7 over negative 4 plus 11i over negative 4. We need to simplify that. Clean it up a little bit. So 7/4 minus 11/4 I. If you write it like this, technically that's not wrong. Just usually you see reals separate from imaginary. So this is something I wouldn't take off in Algebra 1, but as we go down the road, like when we get into AP Calc, you should be splitting them. Okay. All right. Try the next example and then check your work. So hit pause. Okay, here's what we should have done for our final answer. So negative 4 minus 7/2i. So first just multiply by I, distribute it through, simplify powers of I. So I to the second is negative 1, and that's how we get plus 8. And then I squared is negative 1, and that's how we get negative 2. Put the real part first, imaginary part second, and then you can never leave a negative in the denominator, so we simplify it through. Okay, and looks like this is going to stay with us as I go through. But good thing I was able to erase most of it. All right, so the last thing we need to talk about is when there's addition or subtraction in the denominator. So this is just like when working with radicals. You're going to have to multiply by the complex conjugate. So first, in order to figure out the complex conjugate, it is important to write it in standard form. So this is 3 plus 2i. So all I did was put the real part first, the imaginary part second. So its complex conjugate then would be 3 minus 2i. Okay, so when you multiply those two together, just like with the radicals, the i's should all cancel each other out. So 9 minus 6i plus 6i minus 4i squared. Simplify powers of I. So this gives me 9, and then these cancel out, plus 4, which gives me 13. Okay. All right, so let's try an example where we have to multiply by the complex conjugate. So you have to recognize first that you need to do that. I can't just multiply by I due to the fact that there's addition or subtraction in the denominator. Remember, the numerator doesn't matter, it's only in the denominator. So I'm going to multiply by 1 minus 2i. Okay, and so that gives me 7 minus 14i in the numerator. And then the denominator is 1 minus 2i. Plus 2i minus 4i squared. So these cancel out like they should. Simplify powers of I, so that's plus 4. So this gives me 7 minus 14i all over 1 plus 4. So 7 fifths minus 14 fifths I. Okay. All right, we're going to do one more example and then call it a day. So let's jump over to number 3. And sorry for all the erasing. I don't know why Explain Everything does that sometimes. So we first need to multiply by the complex conjugate. So in this example, that would be 7 plus I. It comes from the denominator, not the numerator. So we have to multiply the numerator out. So 14 plus 2i plus 28i plus 4i squared. And then the denominator is 49 plus 7i minus 7i minus I squared. Remember that the whole point of multiplying by the complex conjugate is so that you do not have i's left in the denominator. Do not start canceling things. Do powers of I instead. So this is plus 4 times negative 1, which is negative 4. And this is minus a negative 1, so that gives me plus 1. So I have to add the real parts together in the numerator and the real parts together in the denominator. So that gives me 10 over 50. Okay, these cancel out, and then I need to combine the imaginary parts in the numerator. So this is going to be plus 30i. Okay, and then either look at the heart or kind of do what we've been doing already, which was splitting this. So 10 over 50 plus 30 over 50i. So that's 1/5 plus 3/5 I. All right, I hope you enjoyed the powers of I, and we have one more video for this lesson. Thanks so much. See you later.